Y'all done? All right. All right, we're going to talk about today permutations and combinations. Now, they are very similar, okay? But there's just a slight difference, and the main difference is this. Both of them are dealing with the grouping of something, okay? Now, it can be a whole host of things. It could be an actual object. It could be classes that you're going to have on your school schedule. It could be randomly playing disc or MP3s for a disc jockey, okay? All of those things can be quantified as either permutation or combinations. But it's a grouping of something, okay? Both of them are a grouping of something. And here, and in the book they use objects, okay? But it's not necessarily objects, okay? So that's why it's a grouping of something. A permutation, order does matter. In a combination, order doesn't matter. Okay? Let me give you an example of both of them. Okay? And I'll use school and subjects at school as my example. Now, when you're in math class, obviously when you're in 7th grade, you don't start in calculus, okay? If you did, then obviously you'd be very, very smart and you would already get this, so I wouldn't have to explain it to you. But we don't start off in calculus, okay? You don't start off in, like, for example, our order of math is Algebra 1, Geometry, Algebra 2, Pre-Cal, Calculus. Okay, that's the order. Okay, that is where the arrangement of the objects in a specific order, it does matter. Okay, in other words, you wouldn't want to take calculus and then algebra 1 and then geometry or then algebra 2, then pre-cal. Okay, pre-cal is simply that. It's pre-calculus. Okay, so you take it before calculus. Okay, and so in that scheme of things, it does matter what order that you take the classes in. And so we would consider that as a permutation if we were looking at different schedules for each student. Okay, we have to take in whether they've had the correct class before we can schedule it. Just like, for example, in high school you have English 1, 2, 3, and 4. Well, obviously you don't go into English 4 as a freshman. Okay, you go into English 4 as a senior. So that does matter. Okay, well, let's say that our electives here are art, music, choir. Music and choir are the same thing, really. So we say art, choir, band, and computer. Okay, well, in that scenario, it doesn't matter which one you take first. In other words, I can take art and still go to band next. Or I could go to band and then go to art next. Okay? Now, obviously, we do have, beginner band, stuff like that. But as a sense of the subject matter itself, it's not going to matter whether or not you've had art or computer before you go into band. Okay? It doesn't matter. So the arrangement of the classes, when you take the classes, doesn't matter. Okay? Now, that is a combination. Okay? Where it doesn't matter which class you take first. Okay, and now what we're talking about is this, is when you're figuring out combinations, okay, there's going to be repeats. For example, if I use our same example, if we have, for the combination, we have computer, band, art, and choir. And let's say you're required to take one of them each year when you until you graduate. So you got to have those 4 classes. You got to take one of them each year. Okay? Well, I could take computer, band, art, choir. I could take it in that order. Okay? Or I could take it in choir, band, art, and computer. Okay? Well, it doesn't matter because these are basically repeating each other, because it doesn't matter which one I take first. Okay? They're basically a repeat in the system that you have to figure out. Now, in a combination, okay, we have to consider mathematically those repeats. Okay? We have to consider those repeats, and we have to do something with those. We'll talk more about those here in a second. Okay? Now, let's say that we're running a race. Okay? We're running a 100-meter dash, 110-meter dash. Okay? It's 110-meter dash is what the actual race is. It's 100 yards. Some people say 100 yards in a track meet, but most track meets now are done on metric measurements. So it's 110 meters. So you have 110 meters, and it's a race. Okay? And we're going to have 8 participants. Okay? There's 8 lanes on most tracks, so we're going to have 8 participants. Okay? I want to know how many possible ways that we can place the top 4 people. Okay? I want to know how many possible ways there are for the top 4 places in the race. Okay? Now, what you first have to consider is this a permutation or is it a combination? Nick? Nope. So there's only one left, obviously. Why is it a permutation? Somebody that thinks it's a permutation, why is it a permutation? Zach? Right. Yeah, the order does matter. I know in our society where, hey, you get a participation trophy. Okay? Order, to a lot of people still matter. I mean, the Super Bowl champions get more benefits than the team that picked first, and it's going to pick first in the NFL draft, the Tampa Bay Buccaneers. Okay? Order does matter. Okay? So, in this situation, it does matter who gets first, because here's why. Once I take out the first place person, how many are left? 7. So, you have first place, there's 8 runners. There's 8 people that can slide into that first spot. Okay? Second place, there's only 7 runners left that could slide into the second spot. Once that first person crosses the finish line, there's only 7 more people that can get second. Okay? Third spot is 6. Fourth spot is 5 left. So, to figure out how many possible combinations there are for that, or how many choices, combination's a bad word because we're fixing to use it as a definition, okay? So we want to know how many choices there are, or how many different ways that we can arrange those places. Then we're going to simply take and multiply 8 times 7 times 6 times 5. Okay? And let's see, 0, 8, that's going to be 1,680. Okay? So there's 1,600 or 1,680 different ways that you could place 8 participants 1 through 4 in the 110-meter dash. Okay? 1,680 ways. Now, most of the things you're going to be dealing with today, okay, you're just finding out the number of ways or the number of choices. Okay, there's not a whole lot of probability to it. There are a few that say, okay, what is the probability then that you're going to take and have picked the correct finish? Okay, so you think of, for example, those people that bet on horses. Okay, well, what they're betting on is who gets first or who gets second, who gets third. And so basically it's permutation. Okay, because once the first horse comes across, second, third, all that, then obviously it does matter in the order. What we talked about the other day when we talked about the lottery, and we talked about, you know, there's this ball that comes out, this ball that comes out, this ball that comes out, this ball that comes out. That's a similar combination. It's not a permutation, it's a combination. Okay, why would it be a combination? Well, because it doesn't matter what order the numbers come out in. No, if you pick 1, 2, 3, 4, 5, it doesn't matter if they come out 1, 2, 3, 4, 5, or if they come out 5, 4, 3, 2. Okay, it can come out whatever way you want it to, as long as those 5 numbers come out. Okay, now, then let's say this. Trying to think of another one here. See, there was one that I want to look at. Okay. How many ways are there to choose the president, vice president, secretary, and treasurer? Okay, from an 18, oops, did they include treasurer? Yeah. 18-member club. So there's 18 members in this club. And I want to know how many different ways there are that we could do a president, vice president, treasurer, and secretary, or secretary-treasurer. Okay? So, when we're choosing the president, how many people are there to choose from? 18. When we choose the VP, how many is going to be there? 17. We choose the secretary, how many are going to be there? 16. And treasurer would be 15. So you'd have 18 times 17 times 16 times 15. Okay? Now, somebody multiply that out. Anthony, what'd you get? What? Yes, 73,440. That is correct. 73,440 different ways that you could come up with officers for that club. Okay? Now, let's look at a combination. Okay, let's look at a combination. Let's go back to our example of the electives. We have computer, that we're going to call C. We have band, which is obviously B. We have art, which is obviously A. And we have choir, that we'll call H. Okay? Now, let's change it up a little, and let's assume this. Let's assume that we have these 4 choices this year to take, and I have to take 2 of them. I have to take 2 of the 4. Okay? So we want to know how many possible combinations, choices there are. Now, does it matter? We've already discussed that this is a combination because it doesn't matter what order that we take these things in. We just know that we're going to take one elective, but then once it's taken, we can't take it again, obviously, in the same year. Okay? So, if this was a permutation, then we just simply do what? Well, the first choice, there would be 4 choices. For the second choice, there would be how many? 3 choices. For a total of 12 choices. Okay? But we have ones, it is a combination, so here's what we have to do. I'm going to list them out so I can show you. Okay? Here's the choices. We could go computer band, we could go computer art, we could go computer choir. Okay? Next, we could go band, computer, band, art, band, choir. Okay? Then we could go art, computer, art, band, art, choir. Then we could go choir, computer, choir, band, choir, and art. Now, that represents the 12 that we came up with over there. But here's the problem. Okay? Here's the problem. If I look at this, since order doesn't matter, okay, well, here's computer band. Well, that's the same thing. So that's a repeat. So that's not a different way to take it because it doesn't matter that I take computer and then band or band then computer. Okay? If we look at this one, if we look at next, computer art, well, that's the same thing. If you look at computer and choir, that's the same thing. Okay? Well, then we have band and art. Well, band and art are the same thing as art and band. Then we have band and choir. Same thing there. Okay? Now, we have CA, computer, or CH, excuse me, CH, AH. Do I have an AH? No. Okay, do I have a CH? Yes, I do. Right here is the same as that. So, then realistically, we have 1, 2, 3, 4, 5, 6 actual choices. 6 different ways to take 2 of the 4 classes. Okay? Well, that's a way to list it out and show you, but that's not really realistic to do that. Okay? Because you may have something that has 20 choices, you may have something, and so you can't list out, there's 20 choices and I got to choose 4 of the 20. You can't list those out. I mean, that would take forever. So there's got to be a way mathematically to get it done. Here's the way mathematically that you get it done. Okay? If we look at this, we said you take 4 times 3 if it was a permutation. In other words, order does matter. It does matter if I take art before choir or choir before art. That does matter. That's what we would do. Okay? Well, how many choices am I trying to make here? How many classes do I have to take? 2. I have to take 2 classes. So, 2 classes is 2 times 1 on bottom. So that's 4 times 3, which is 12. 2 times 1, which is 2. Divide 2 into 12, you get 6, which matches this over here. Now, if you were choosing 3 of the 4, okay, if you were choosing 3 of the 4, it would be, okay, 4 for the first one, 3 for the second one, 2 for the third one. So 4 times 3 times 2, which would be 24. Then on bottom, it would be, since there's 3 choices, 3 times 2 times 1. So if there's 10 choices out of the 20, then it would be 20 times 19 times 18 times 17 times 16 times, okay? And then on bottom, you would have 10 times 9 times 8 times 7 times 1, just like that, okay? So let me give you another example. Let's say there were 40 items. No, I don't want to go that high. Let's say there is 20 items, and I choose 5 items. Doesn't matter. I got 20 different baseball cards, and I choose 5 of them. Okay? Obviously, order doesn't matter. So I would take, then, 20 items, and I choose 5. So the first item, there would be, if I'm going to choose 5 items, 5, 4, 3, 2, and 1. For this one, there's 20. For this one, there's 19. For this one, there's 18. For this one, there's 17. And this one, there's 16. Okay? So I would take 20 times 19 times 18 times 17 times 16 on top. I'm choosing 5 items. So that would be 5 times 4 times 3 times 2 times 1 on bottom.
I got it.
However many items there are that you're choosing, okay, if you're choosing 12 items, then on the bottom of the combination would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, and you would divide it. Okay? Do what? Obviously, you have a question, ask it. Okay? When you say you don't get it all, that means you don't know how to multiply 20 times 19. Are you not understanding where I'm coming up with the numbers? Which ones, top or bottom? Okay? Top is the number of choices that you have for each thing. Okay? That means if I've got 100 items, okay, and I want to choose 2 of them, let's say, make it easy. I want to choose 2 items out of the 100. What are the total possible choices that I could come up with for those items? Okay? Then I would take, there's 100 choices when I pick my first one, right? When I take the first one out, then how many are left when I pick the second one? 99. So it would be 100 times 99. That's how many total possible choices of things I could pick out of the bag, box, whatever it is. Okay? Let's say, but it doesn't matter. For example, here's a great way to explain it. Putt-putt. When we go to putt-putt every year, and you do the little thing that's got the crank, and it goes down and it picks something out of, like the stuffed animals that it picks out. Okay. Let's say there's 100 stuffed animals in there. Okay. Does it matter which one you pick out first? Not unless you just have a preference. Let's say you don't have a preference. So I'm going to pick out 2. So I go down, pick one out, throws it in the thing, go down, pick another one out, throws it in the thing. Okay? They're all different, all 100 different items. They're all different animals. Okay? So you would find out, well, the first one, there's 100 possible choices when I dig in and pull it out. I drop it in the thing, I dig in, pull out another one, there's 99 possible choices. So now there's 100 times 99, okay, which is 9,900. So there's 9,900 possible combinations of animals you could pull out of that thing. But let's say you pulled out a rabbit and a pig, okay? Well, you could have pulled out the rabbit first and then the pig, or you could have pulled out the pig then the rabbit, right? Okay? Hey. Turn around and face front. Okay? So, you take then, since those combination doesn't matter, there's two items I pulled out. So I take 2 times the 1 to get rid of all the repeats, the different repeats I could have had. There's 2 repeats I could have had. I could have had rabbit, pig, or pig, rabbit, correct? Those are the 2. So I need to take those possible combinations out of it. And so I take 9,900 and I divide it by 2 times 1, which is 2. So I divide 9,900 by 2. Okay, that's 950. Okay, 4,900. So there's 4,950 possible choices in that bin of animals. And that's what you get. Now, if you're picking out 4, then it would be on the bottom. On the top, you would have 100 times 99 times 98 times 97. Because each time I pull one out, I got to decrease the total that's in there. And then on bottom, I'd had 4 times 3 times 2 times 1. And that's how, and I would divide it into it to find out what that is. Okay? Let's look at some actual examples out of the book. Now, when you do this, okay, 20 times 19 times 18 times 17 times 16, then you have 5 times 4, 20 times 3 would be 60, times 2 would be 120. So you would take 120 on bottom, okay, and let me do this real quick here. Hey, they're about to go out of the classroom, understand? Okay. So 109,440. Okay, that's what you would divide 120 into 109,440. Okay, so if we do that, you get 912. Okay, so there's really only 912 possible different combinations of items that you could pull out doing the 5 items. So that's 920, is that what I said? 912. So there's 912 total different choices that aren't repeats of each other that you could choose. Okay? Now, if it did matter that you know, like I was using the one with Zach, if it does matter that I pull out the rabbit first, then the goat, then whatever, then obviously it's a permutation, and then there's 9,990. 9,900. Okay, and that's a total different ways if it matters what order they come out in. Okay, now let's look at some examples out of the book. Everybody look at 8 through 12, or 8 through 11 actually. Okay, 8 through 11, it tells you on these that they're permutations. In other words, order does matter. Okay, if you think of a batting order, if you take 9 people and you've got a batting order, it does matter what order they're in. Okay, it does matter who's in first slot, who's in the second slot, who's in third slot, all that. Okay, sample permutation says, number 8 says, ways to arrange the letters in the word guitar. In other words, if I use the letters in the word guitar, how many different ways can I arrange them? Well, it does matter what order they're in because, you know, they may spell a guitar, they may spell something else. So, how many letters are in the word guitar? 6 letters. Okay? So if we have guitar, Okay? There's 6 letters. Okay? So I want to know how many ways that I can rearrange those letters. Well, it's a permutation because once I take the G out, there's no more G's. Or once I take the U out, there's no more U's. Okay? And it does matter because of the word it may spell. It does matter what order the letters are in. Okay? Because there's 7. If you take this then, for the first letter, there's 6 letters. So for the first letter, there's 6 choices. For the second letter, there's 5 choices. For the third letter, there's 4 choices, 3 choices, 2 choices, 1 choice. And I multiply those together. Okay? That's 720 different ways. Okay, that's how many different ways that you could rearrange the letter in guitar. Okay, we've already done number 10. Okay, I've already sort of done number 11 with our track example. Turn the page over to page 654. Number 13. Number 13 says, ways to choose 3 different kinds of apples from the following kinds. Okay, so we have 3 different apples we want to choose. Okay, there's 3 apples that we want to choose from 5 different apples. Okay, they have Red Delicious. They have Granny Smith, excuse me. They're using my name, I ought to sue them. Granny Smith. Empire, Macintosh, and Fuji. I thought that was FIM, but I guess not. Okay, so there's 5 different apples. It does not matter the order that you choose the 3. In other words, you don't have to choose a Red Delicious to be able to get the Granny Smith. Okay, you can get them. You can get any of those. It doesn't matter. So for my first apple, there's going to be 5 choices. For the second apple, going to be 4 choices. For the third apple, there's going to be 3 choices. Now, we are not done here. This is a combination. Okay? So you're going to have 5 times 4 times 3 on top. Okay? On bottom, how many places or how many choices do I have? 3. So on bottom, you start with the 3, then you multiply it by 2, then you multiply it by 1. Okay? So on top, we have what, 36? No, 60, excuse me, 60. I was thinking, 60. 3 times 2, obviously we don't have to multiply by 1. It's just 3 times 2, which is 6. So there's 10 choices. 10 different ways that I could choose 3 apples out of the 5. Now, obviously, if you were choosing the 5 apples, if you're choosing 5 apples out of 5, then there's only, and the order doesn't matter, then there's only one way. Because they're all repeats. Okay? No, it would be 1. Because on top you'd have 5 times 4 times 3 times 2 times 1. On bottom you'd have 5 times 4 times 3 times 2 times 1. Okay? So, that's how we do the combination. Now, look at number 18. Number 18 is a fairly long one. I am going to let you use a calculator on. Okay? Because here's why. It says it wants you to pick 6 cards out of a deck. 18. 6 cards out of a deck of 52 cards. And it says, for whatever reason, order is important. Okay? So you would have 6 cards, so first card, second, third, fourth, fifth, sixth. Okay, so obviously for the first card we have 52 choices. Second card we have 51, then 50, then 49, then 48, then 47. Okay, that would be a lot of work. Okay, so I will let you use your calculator on 18. Yep. All right. Now, let's look at 19 through 22. No, you do not divide that one because it's permutation, because they said order does matter. So it's just whatever that number is. Even if it was a combinations act, you'd have to take 6 times 5 times 4 times 3 times 2 times 1 is what you would divide by, not just the number 6. 19. How many ways can a disc jockey choose 4 different songs from 10? Is that a combination or a permutation? Does the order matter? No. So then it's a combination, okay? So that's a combination. Yeah, that's part of the answer, but then you have to find how many choices there are as well, okay? How many ways can you choose 3 different pizza toppings from 15? Is that a combination or permutation? Combination, because order doesn't matter. Okay, it doesn't matter if I choose, salami before I choose anchovies. Okay. Then it says 21. How many ways can a judge award first, second, and third places at a science fair with 23 entries? Does order matter? Yes, order matters. So it's a permutation. Okay. So you have to do 2 things. That's not all you have to do. You have to tell whether it's a combination or a permutation. Then you actually have to figure out what the choices are. So you actually got to do the math as well once you figure out it's a permutation or a combination. Okay? So your homework. Your homework is 13.4. And you're going to do 1 through 22. Okay, you got 1 through 22. Still got about 7 minutes left. You can get probably quite a bit of that done if you'll work on it right now.